Rectangular components of electric field. Today we will discuss about the component of electric field along x-axis, y-axis and z-axis. Let us suppose that there is a charge plus q placed at the origin and E be the electric field at point P. The direction of electric field will be along the position vector r. You can find out the direction of electric field at point P by placing a unit positive charge +1 coulomb charge at point P. When we place this charge, it will try to move this direction, along this direction, because it will experience a force due to plus q charge placed at the origin, and the direction in which it will experience the force will be the direction of electric field. Let r be the position vector of point P having coordinates x, y and z. Now this position vector is written as r equal to xi cap plus yj cap plus z k cap, and the magnitude of this position vector, that is mod of r, is equal to under root x square y square plus z square. Electric field E is equal to exi cap plus eyj cap plus ez k cap. We know that electric field due to plus q charge is equal to q upon 4 pi epsilon naught r square r cap. R cap is the unit vector along the direction of electric field. So r cap is written as vector r upon mod of r. Now if we put the value of r cap at here, this will becomes equal to q upon 4 pi epsilon naught r square r vector upon r, or q upon 4 pi epsilon naught r cube r vector. When we put the value of E, r vector and mod of r, we will get this one. Now here, if we equate the coefficients of I cap, j cap, k cap on both sides, you will get Ex equal to this one, Ey equal to this much and Ez equal to this much. Now if x equal to y equal to z, then Ex will be equal to Ey equal to Ez. This shows that at equal distance from the charge along x-axis, along y-axis and along z-axis, the electric field has the same value. At equal distance from the charge, electric field has the same value. Means the value of electric field at this point, this point, this point will be same. Or if we assume a sphere around this charge plus q, then electric field due to this charge will be radially outward, like this. Or electric field has spherical symmetry, that is at equal distance from the charge, electric field has the same value. Or if we assume a charge placed at the center of the sphere plus q charge, then electric field at the surface of the sphere will be same. This shows that electric field due to a point charge has spherical symmetry. Electric field in terms of coordinates is given by this formula that we have derived earlier. Now superposition principle. This is a very important principle used in numerical problems to find the net electric field or net force or net electric potential due to the charge configuration. Suppose that we have a number of charges q1, q2, q3, q4, q5. q1, q2 are positive, q3, q5 are negative, q4 is positive. If we have to find the net force on charge q1, q1 due to q2, q3, q4, q5, then what will be the net force? Now q1 will be repelled by plus q2 charge along this direction, and it will be attracted by charge minus q3 along this direction because both are unlike in nature. And q4 will also repel q1 along this direction. q5 will attract q1 along this direction. So if we see that the F12 is along this direction represented by this vector F13 along this direction, F14 along this direction, F15 along this direction. This is your F12, F13, F14, F15. So these vectors are in same order, and we know that resultant will be in opposite order. So this will be the resultant, and this will be equal to F12 plus F13 plus F14 plus F15. So the net force on charge q1 is the vector sum of the force exerted by other charges on charge q1. So according to principle of superposition, electrostatic force experienced by a charge due to other charges is the vector sum of electric force due to the other charge. The force due to individual charges is not affected by presence or absence of other charges. Here we have to take only the force F12, F13, F14, F15. We are not considering here the force between Q2 and Q3, Q3 and Q4, Q4 and Q5. The force between these charges Q2, Q3, Q3, Q4 will not affect the force due to individual charges. Means between Q1, Q2, Q1, Q3, Q1, Q4. So net force will be the vector sum of the force which each charge would exert on the given charge. In terms of position vectors. Now if we consider a charge q naught having position vector r naught and q1, q2, q3 are the other charges placed around the charge q naught. Now the force experienced by q naught due to q1 will be F naught 1. Force experienced by q naught due to q2 will be F naught 2. Force on q naught due to q2. F naught 3 is the force on q naught due to q3. So according to principle of superposition, net force will be the vector sum of force between q1, q naught, q naught, q naught, q2, q naught, q3, so on. Now F naught 1 means force between q1 and q naught is written as 1 upon 4 pi epsilon naught q naught q1 r1 naught. R1 naught is the unit vector. R1 naught is the unit vector from q1 to q naught. That is R1 naught cap. This will be along this direction. F naught 2 is the force between Q naught and Q2. That is F naught 2. F naught 2 will be equal to 1 upon 4 pi epsilon naught Q naught Q2 R2 naught square R2 naught cap. R2 naught cap is the unit vector from Q2 to Q naught, and this is R2 naught cap. This will be along this direction, along the direction of F naught. Similarly, the force between Q naught and nth charge, 1 upon 4 pi epsilon naught Q naught Qn R n naught square R n naught cap. So net force, when we put the value, all these values at here, then we will get this expression. Now this can be written as 1 upon 4 pi epsilon naught I equal to 1 to n Q naught Qi Ri naught square Ri naught cap. I is the ith charge. It can be Q1, it can be Q2, Q3, Q4, so on, Qn. Now, if we write F naught equal to 1 upon 4 pi epsilon naught I equal to 1 to n Q naught Qi Ri naught square Ri naught cap, then Ri here is Qi is the ith charge, Ri is the position vector of ith charge. If Q is the ith charge, Ri is the position vector of ith charge, and Q naught charge having position vector R naught. Now Ri naught is the position vector from ith charge to Q naught, having unit vector Ri naught cap along this direction. So Ri naught can be written as, these two are in same order, this is in opposite order, so the resultant is this one. Ri naught can be written as R naught minus Ri, and its magnitude is written as mod of R naught minus Ri. Now if we convert this unit vector R cap I naught, this can be written as vector Ri naught upon mod of Ri naught. Mod of Ri naught. So if we put this value, at here, then we will get this expression. And F naught, when we put these values, we will get F naught equal to R naught minus Ri mod cube R naught minus Ri, and electric field is Fy Q naught. If we divide this expression with Q naught, we will get this expression. This is the expression for electric field in terms of position vector. So the superposition principle is applicable to electric field also. The electric field intensity at any point due to a group of point charges is equal to vector sum of electric field intensity due to individual charges at the same point. So E equal to E1 plus E2 plus E3, so on En. So the same law is applicable to electric field also.